Hello and welcome to the second video for natural and common logs. We're going to start working with these guys. Just a quick little blurb on how LNs work in the like formulas real fast, just in case, so you can see how you'd use those there. We've got 4 ln of 3x is equal to 8. Okay, so imagine this is the same routine as any other equation. Honestly, the ln is not the first issue here. The 4 is. So how do you get rid of a 4? Divide by 4. We get ln of 3x is equal to 2. Now we do the ln idea. Well, just like when you have log base 2 of whatever equals whatever, and you move the base to the other side, the same thing's going to happen here. I'm going to move this ln to the other side as a base of e. And so we get e to the second. The difference is now I can't calculate e to the second. I mean, I could, we did, but I don't want to write this hideous decimal down, right? It's kind of like writing pi versus 3.14. I want to be as accurate as possible, so I'm going to leave it as e to the second. Last thing I need to do for x is divide by 3. I get that it's e to the second over 3. Cool. Let's look at that one again. We'll go over here. Kind of the same idea. Almost the exact same numbers. Divide by 3, you get ln of 4 to x equals 4. Now, once again, ln, you want to take it to the other side. That's going to be an e base on the other side. I do not get 4e. I get e to the 4th. Remember, this is a logarithm. You're talking about exponents here. And so when you undo that, you're not just trading it to the other side for an e and doing 4e. It's e to the 4th. Okay, that thing on the other side is still an exponent. Now we divide, and we get our final answer of e to the 4th over 4. Cool. All right. We'll work a little bit with those a little bit more towards the end of the chapter as well. The next thing we want to talk about is the change of base formula. These two buttons in the calculator are only so cool if we can use them for a lot of things, right? If they weren't very useful, they probably wouldn't be on every single calculator that you come across, right? But you can use these for every single calculator you come, or on every single calculator you come across. You can use these for any function that you need to, and you can do it by this rule here. This is called the change of base formula, and it's arguably one of the most important formulas when dealing with logs. Honestly, if you box nothing else this time, just box this guy, okay? What does it mean, though? Basically, what it says is if you have a log of some type, okay, let's do classic log 2. Okay, you have log 2 of 32. Well, we know this equals 5, right? We know this equals 5, but let's say we didn't know that. We didn't want to sit here. We want to figure out how we could figure out what power of 2 is going to go to 32 without having to punch in a bunch of 2 to the 2 to the 2 to the 2 to the, right? What if we wanted the calculator to spit out that answer for us? What we could do is we could choose either common log, log base 10, or natural log, whichever one you prefer, and we could rewrite this in those terms. I'm going to go with common log. Actually, I'm going to go with natural log because it's a little easier to see the difference. So natural log. I'm going to put the argument on top and the base on the bottom. And I think that's a beautiful consistency that the base stays in the bottom. This whole chapter, that base is staying in the bottom of the expression. It's in the log bottom. It's below the exponent. It's below in the change of base formula. So it stays in the bottom. Now, calculator here. ln of 32 divided by ln of 2, not 20. We see that 5. It has spit out that 5 for us. So we have figured out log base 2 of 32. Even though there's no button for log base 2 in the calculator, we can figure out that it's equal to 5 because of this change of base formula. So let's do that a couple more times now. Let's take a look at a couple more. We've got log 5 of 2. I'm just going to prove to you it does work with common log as well. Argument up top, base in the bottom. Now, careful, don't do log 12 divided by 5, sorry. Don't do log 12 divided by 5. You want to do log 12 divided by log 5. You have to have logs on both sides. So log 12 divided by log 5, 1.543544. Now, let's double check. Okay, what power of 5 goes to 12? Well, 1 would be 5, 2 would be 25. That's about halfway in between. Yep, it sounds right. Good job. All right, let's do another one. Log, of 4.6 log of 12.8 divided by log of 4.6 because of this situation over here, right? We get 1.671. Yeah, 4 squared is 16, so 4.6 squared has got to be bigger than 16, so it can't be more than 1. 1.6 sounds good. Okay, cool. Last one, log base pi of e. That one's horrible. So let's use ln of e, which we know to be 1, divided by ln of pi, we get 0.8736. I don't know why I'm going so many decimal places, but yeah. Okay, cool. So even with numbers that are irrational, even with numbers that are crazy and long and all over the place, you can still pull out this change of base formula and you are good. All right, let's use this change of base formula to solve an application in the next video. See you there.